Welcome back. We'll continue solving systems of linear equations using this method of row reduction. Here we have an SLE given in standard form, and the first step in our process is to convert this into an augmented matrix. So I'll put that in column by column, 1, 0, 1, the coefficients in front of x, and the coefficients in front of y, 1, 2, 3, and the coefficients in front of z, 1, minus 1, 0. And then the right-hand side, 2, 4, 5. It starts off in a nice way. At the top left, we have a leading 1, and it's almost happy. There's only one thing it has to destroy. This is our source of unhappy. And we'll use the leading 1 to destroy it. Okay, so I'm going to replace the problem row with itself minus 1 times row 1, because that's the operation that will convert that into a 0, making the top left leading 1 happy. So row 1 stays the same, 1, 1, 1, 2. Row 2 stays the same, 0, 2, negative 1, 4. And row 3 becomes 1 minus 1, 0, 3 minus 1, 2, 0 minus 1, negative 1, and 5 minus 2, 3. Now, next thing we can do is we could create a leading 1 in the middle. So divide by 2, row 2. So we'd have a 1, negative 1 half, and a 2. But let's hold off on doing that. Notice that we have an almost pair of duplicate rows. Row 2 and row 3 are almost the same. They're off by a number. So let's do a subtraction. Let's do that before making leading 1s. We're kind of going out of order, but it's okay. There's a reason for it. So the next move is I'm going to replace row 3 by row 3 minus row 2. It's nice to zero things out. I guess if you're wondering why did I choose to do this, well, I can zero a lot of stuff out this way. I can make smaller numbers, make my subsequent steps easier. Like that's my thinking right now. 1, 1, 1, 2, 0, 2, negative 1, 4, and now 0 minus 0, 2 minus 2, 0, negative 1 subtract negative 1, which is 0, and then 3 subtract 4, which is negative 1. Okay, any comments or concerns when you stare at the matrix? Maybe press pause and look at it. Okay, hopefully you pressed pause and looked at it and you said that you're done, we're finished, there's no more work to do, because the last row is impossible. The last row is stating that there's some x, y, and z value for which 0 times that x value plus 0 times that y value plus 0 times that z value will give you minus 1. And it can happen. So we are done. There is no solution. Since row 3 says 0x plus 0y plus 0z is equal to negative 1, which is impossible. This is the greatest thing that can happen because there's no more work to be done. There's no more row reducing. We don't have to state anything with t. We're finished. No solution. Okay, and then I think this is the last. No, it's not the last. All right. This doesn't look very nice. It's got some big numbers in it. I'm worried about creating fractions, but let's see what happens. So first step, put the numbers in the matrix. 2, 0, 7, negative 1, 2, negative 5, 3, minus 1, 0, 24, 14, 6. the orthodox approach that we're supposed to follow is we are supposed to create a leading one right away, somewhere, top left, or so divide row 1 by 2, or bottom divide row 3 by 7, and then swap a row. I'm not going to follow that orthodox approach because I don't like fractions. I hate fractions so much that what I'm going to do is I'm going to show you a trick to avoid them. How can I turn that 7 into a 1 using the 2 as a weapon? Well, what happens if I subtract 3 row 1 from row 3? I'll have 7 minus 6, which is 1. Now I have a leading 1, and no fraction step is required to get that leading 1. So it's not orthodox. It's not part of the standard procedure, the standard practice. A robot would not do this. If you programmed a computer to do row reduction, it would just say, hey, I'm going to make a fraction, I don't care. But let's not be robots. Let's think strategically. If we don't want to avoid a fraction, how can you do it? Can avoid fractions, at least in the early steps. I don't know if it's going to happen later. We'll get stuck. We'll have no choice. But I can avoid fractions now by being clever. And it isn't like remarkably clever. It's not like astronomically brilliant to think this way. Once you see one person do it once or twice, you get the hang of it and you start looking for those opportunities to avoid the fractions. And maybe you're not worried too much about fractions because you haven't tried any of these on your own. Just wait. When you start doing these on your own in homework or doing the practice tests, you'll see what happens. As soon as you start creating fractions, it's a nightmare. So you work as hard as you can to prevent that from happening for as long as possible. So I'm going to take row 3 and I'm going to replace it by row 3 minus 3 row 1. This is to create a leading 1. Without creating fractions. So row 1 stays the same, 2, -1, 3, 24. Row 2 stays the same, 0, 2, -1, 14. And row 3 becomes 7 minus 3 times 2, which is 1, minus 5 minus 3 times -1, which is -5 plus 3, which is -2. And then 0 minus 3 times 3, which is -9. And then 6 minus, well, I'm starting to have regrets, but nothing can be done about it, 3 times 24. So what's that going to be? 3 times 24 is 3 times 20, 60, 12, 72, 6 minus 72. So 72 minus 6 is 66. Yeah, 66. So -66. Okay, now I have a leading 1. I'm going to get the leading 1 in the correct position. I'm going to do a swap. I'm going to swap the order of row 1 and row 3. I really enjoy doing this with a full class because someone will put up their hand and will say, sir, it's not -66, it's -68. Like, oh, I can't add, but I just got to keep going and see what happens. We'll check our answers at the end anyway. Okay, so we're doing our swap between those two rows. 1, -2, -9, -66. And there's usually like murmuring in the background, or some angry noises. What's he doing? Oh my God, I don't understand what's going on. I missed that. Okay, Next step, we have a leading 1 in the top left, but it is not happy. We have a source of unhappiness. We have that 2 that must be destroyed. So we're going to destroy it. We're going to replace row 3 by row 3 minus 2 times row 1, using that leading 1 as a weapon. Okay, so row 1 is going to stay the same. 1, negative 2, negative 9, 0, 2, negative 1, negative 66, 14. Now we've got to be careful. 2 minus 2 times 1 is 0. Negative 1 minus 2 times negative 2. So that's negative 1 plus 4, which is positive 3. Now we have 3 minus 2 times negative 9. So that's 3 plus 18, which is 21. And the last one, we have 24 minus 2 times negative 66. So it's 24 plus 132. So it's 156. Let's leave that alone for now. Okay, next thing. We can divide row 2 by 2 and create a leading 1 there. Or we can divide row 3 by 3 and create a leading 1 there. 3 divides evenly by 3, 21 divides evenly by 3, and 156 divides evenly by 3. 156 is equal to 150 plus 6. So 156 over 3 is equal to 150 plus 6 divided by 3, which is 150 over 3 plus 6 over 3. 150 divided by 3 is 50. 6 divided by 3 is 2, so this is 52. So row 3 we're going to replace by row 3 divided by 3. You will not have such numbers on your tests or quizzes. And I think this is just an artifact of me being desperate to avoid fractions, why these big numbers are happening. So we're going to have 1, negative 2, negative 9, negative 66, 0, 2, negative 1, 14, and then 0, 1, 7, 52. And the trick was to decompose 156 into a sum of two numbers that each divide by 3, or at least one number that divides by 3 and the other number doesn't have to. Then you have a mixed fraction. But whatever. I don't know if they teach that. I don't think they teach that. I don't think they ever taught that for dividing. All right, next thing is we have another source of unhappiness. We have a leading 1, and it's in the wrong spot, so we should really do a swap. So we'll do a swap, row 2 and row 3. So row 1 is going to stay the same. Now we'll do the swap with the other two rows. Oh, not yet. 0, 1, 7, 52. 0, 2, negative 1, 14. Okay, and we have sources of unhappiness. source of unhappy, source of unhappy. So we've got to zero those out using that leading one in the middle as a weapon. So I'm going to replace row 1 with row 1 plus 2 times row 2. So I'll do that as a move. We have 1 plus 2 times 0, which is 1. Negative 2 plus 2 times 1, which is 0. Negative 9 plus 2 times 7, so negative 9 plus 14, which is 5. And then, I don't like this, negative 66 plus 2 times 52. So negative 66 plus 104. So if I subtract the 6 first, I get 98. And subtract the 60, I get 38. So 38 goes here. And then I also have to replace row 3. Row 3 gets replaced by row 3 minus 2 row 2. Row 2 stays the same, 0, 1, 7, 52, and row 3 becomes 2 minus 2 times 1, which is 0, or 0 minus 2 times 0, which is 0, 2 minus 2 times 1, which is 0, and then negative 1 minus 2 times 7. So negative 1 minus 14, negative 15. And the last one I'm really hoping is a multiple of 15, or we're in deep trouble with fractions. I made a mistake somewhere. We have 14 minus 2 times 52, which is 14 minus 104. So 104 minus 14, 100, so 90, negative 90. And our prayers have been answered. Or at least my prayers have been answered. You've probably given up all hope looking at this example. And I promise you will not have anything this bad on a test. Okay, and the reason I'm happy is that you can divide 90 by 15 and not create a fraction. Think about it this way. What's 2 times 15? 30. 30 fits into 90. So 15 has to fit into 90 as well. How many times? Well, if you divide, let's say you multiply it by 2, you get 30. Multiply that by 3, so multiply it overall by 6 to get to 90. Anyway, I'm going to take row 3 and replace it by row 3 divided by negative 15. And we'll get a nice number, a nice matrix. 1, 0, 5, 38, 0, 1, 7, 52, and then 0, 0, 1, 6. And we're almost there. We almost have the answer. I might be able to squeeze it in. So the last pair of moves, so I'm going to replace, because of the source of unhappiness, we have a 5 and a 7 that have to be zeroed. I'm going to replace row 1 by row 1 minus 5 row 3, and I'm going to replace row 2 by row 2 minus 7 row 3. And make sure I know my times tables. So row 1 becomes 1 minus 5 times 0, 0 minus 5 times 0, 5 minus 5 times 0, which is 0, and then 38 minus 5 times 6, so 38 minus 30, which is 8. nice small number. Then row 2 becomes 0 minus 7 times 0, 1 minus 7 times 0, which is 1, 7 minus 7 times 1, which is 0, and 52 minus 7 times 6, so 52 minus 42, which is 10. And the last number is 0, last row 0, 0, 1, 6. And we have our solution. We'll use a red arrow. So our solution is, where's my bracket? Our solution is x is equal to 8, y is equal to 10, and z is equal to 6. Now let's just do a quick check of row 1. So row 1 is 2 times 8, so 16 minus 10 plus 18 equals 24. Is that true? 16 minus 10, 6. 6 plus 18, 24 is true. So it's probably right. No errors were made, I think, I hope. If errors were made, let me know. We'll continue in the next video.